All right, so linear modeling. So we're dealing with linear modeling. What we're dealing with here is real world data or sets of ordered pairs that may come from different scenarios. So it's kind of like the word problem stuff from last section, but instead of having specific things about the price of an object or something like that, we have data points that we can put into a scatter plot and then determine the equation that best fits that particular data. What we're focusing on in 4.2 is linear data. As we go through the course, quadratic data exists. We could get into polynomial data that maybe has a curve to it more than just a parabola. You can get into exponential or logarithmic things. All of these types of equations, your calculator can help you find those. So we're going to talk about, since it's linear, talk about finding that equation by hand and then also finding the equation of best fit using the graphic calculator. So we're going to do two different things in this particular lesson. So let's quickly review what's going on here with these pictures. I've got coordinate plane drawn, and then the blue dots are just the ordered pairs that I made up. And that red line that goes through there is what we're calling a line of fit. And when we look at that one, what does the slope of that line look like in general? It's going up. You see underneath there, I wrote y equals mx plus b, and then the m is greater than 0. So that is a positive slope on that line. Since we're dealing with data, we can call that a positive correlation, or even more specifically, because the data follows a line, kind of in general, it kind of shapes like a line. We can call it a positive linear correlation out of that. Same thing here on the next picture. We got ordered pairs. They kind of fall down to the right, so looks kind of linear. So we get a negative linear correlation out of that. So being able to look at the scatter plot and tell what kind of picture we're dealing with is one thing that once we, chapter 4 test, we put it all together. You got to be able to recognize: do we have linear data? Do we have quadratic data, or something else out of that? So scatter plot's a big part of that. Those sets of ordered pairs in the homework for 4.1, where you have to decide if the sets of ordered pairs or the table was linear data. Can we check that with the slope? This is just another tool to check to see if it's linear or not. Look at the scatter plot. If it looks kind of like a line, it probably is. Okay. If it looks like it's got a curve, it probably is not a line. Okay. So that's the idea there. So positive correlation up and to the right, negative linear correlation down and to the right. And then you've got a couple of other scenarios that we're familiar with. Horizontal, or set of data where all the points kind of have about the same y value, no matter what the x value was. That would be horizontal line, y equals some number with a slope of 0, or something slope close to 0 there. And that's just a horizontal correlation. And then here on the last picture, the data kind of follows a pattern, but it's not a straight line. So kind of a pattern, but not a straight line, is nonlinear. If it's just random dots, like just everywhere, and there's no really pattern to it, then there may not even be any correlation at all. But here with this picture, we see some sort of correlation, but it's not a linear correlation. It kind of follows maybe a parabolic shape, something like that might be what's going on. We'll talk about that later in the chapter about finding that equation and stuff we can do with that. So the idea here in this section is talking about linear things. So we're going to do two things. We're going to, one, find the equation of a line the way we already know how, by hand, which I tell you which two ordered pairs to use, and then you spit it out. Or in the homework, you'll have to pick two ordered pairs and go from there. So let's start with a set of data that I've just made up here. So these are x and y values that you would be given in a scenario. Those x values may be, number of, number of hits you got, or number of at-bats you got in a week or something like that. And then the Y values may be the number of hits you got. That may be what's happening here. Doesn't really matter where the data comes from. We're going to find a line of fit. So we're going to find a line of fit. That's when you say line of fit, that is by hand. We're going to find a line of best fit. So if you see the word best, that's with the calculator. So line of fit is by hand. Line of best fit is going to be with the calculator. So if we're going to find a line of fit, first we need to decide, is the data linear out of that? So what I'm going to do is I'm going to do a scatter plot with my graphing calculator. So with the graphing calculator, pull that out, and let's get everybody set up, ready to do the same thing. So everybody's getting the same information when we find that equation later. All right, so everybody hit the mode button. Down there, scroll down until you see a line that says Stat Diagnostics. And then turn that to on. Everybody's to be turned on. And if yours doesn't show that, you can't find it, let me know, and I'll try to help you find it. Mode. Look for Stat Diagnostics and make sure it's turn it on. Probably defaulted to off. Okay, so that's going to get us a little bit more information out of that. And then there should be one that says Stat Wizards, and we want to make sure that's set to on so everybody's screen. Anybody not seeing those or not getting those set right? Okay. All right. So once you've set that up, you don't have to go back and do that again. It stays that way until maybe you reset your calculator or something like that. All right. So now, next thing is putting this data into a scatter plot. So we're going to hit the Stat button, and then we're going to hit Edit. So we just hit Enter right there. And I've already got some lists in here, and I need to get rid of these and use the data that we have in our example. So I've got a list that's already in there. You likely do too from another thing. So we're hitting the Stat button and then hitting Enter on Edit, and that'll get you there. Does anybody not have list 1, list 2 there? Maybe yours just has list 1, and then the next one's list 3 or list 4 or something like that. Anybody's not showing those things? Okay, then we don't need to do the other thing. All right, so now to clear out a whole list, press the up arrow till it highlights the name of the list, and then hit Clear, Enter, and it'll dump everything out of there. Same thing I'm going to do on list 2. Press the up arrow, Clear, Enter, and that deletes out an entire list, all the data in that list. What we want to do is put in our X values in list 1 and our Y values in list 2. So I tried to make it easy on us to remember what they were instead of random numbers. I did the odd numbers from 3 to 13 for the X values. So that's what we're going to use there. So X values are 3, 5, 7, 9, 11, and 13. And then the Y values that go with those, 0, 2, 3, 6, 9, 11. 0, 2, 3, 6, 9, 11. Okay. Make sure you put them all in the proper order so that the ordered pairs are matched up. If you mix up one of them, changes everything. Okay. So be very careful when you're putting your data in. Double check things. Okay. Everybody got your data in? All right, now let's make it do a scatter plot. So to make your calculator draw this and plot those points, we're going to hit second and Y equals. And that should take you to the stat plots screen. And we're just going to select stat plot number 1 and press enter. And that should take us to this screen. Right now, my stat plot 1 is currently turned off. I want to turn it to the on position so that it is ready to plot some things. And then the type, there are several types your calculator will do. The first one is a scatter plot. The second one is a line plot, which basically is a scatter plot with the dots connected with lines. That's all that really is. The third one's a histogram, which you'll use if you take stats. We'll use that a good bit. And then fourth and fifth are both box and whiskers. Yes, sir.
Will that second one be good for like determining the graph of something based solely on like X and Y values?
No, it doesn't really. It's more like have you ever seen the graphs where like you're tracking stocks, where it shows how much like that line, if you're looking at in between individual points, that's where it's at. The scatter plot, finding the trend, the first scatter plot is really the best one for the trend. The line in between them is really like finding what's happening in between certain points is really what it's best for. Then, so we want on and then the first type selected. That's what we want to use there. And then X list should be L1. Y list should be L2. So anybody's not that. Okay. You shouldn't need to change that at any point there. We're all just going to use the L1 and L2. What mark you use is up to you. I use the box there, the very first choice, because I can see it. And the rest of them, the plus sign's pretty easy to see. But when you get into putting just these little dots here, I like the box because I can see well. If you got the color version, you get to pick your color. We're going to stick with the default there, which is blue, which is just the first choice. All right, and then we're going to hit graph. And you probably are going to see a little bit of something, but not everything. I happen to have an equation in there, so I want to go to y equals and clear that out. So I'm clearing out all the equations I happen to have. And I can see part of my ordered pairs, but not all of them. So I want to fix my screen to where I see all of the ordered pairs in the scatter plot. So to do that, you're going to hit zoom and then number 9 for zoom stats. What that'll do is it'll adjust your window to fitting the scatter plot for the ordered pairs you have in L1 and L2. Does that look fairly linear? Is it perfectly linear? No, it's not perfectly linear. This is the difference in the ordered pair sets today and the ones you saw yesterday in 4.1, where it was perfectly linear. These are not perfectly linear, but they trend to be linear. So the idea of a line of fit is basically eyeballing it. So you're taking a straight edge and you're looking at your scatter plot and you're trying to pick out what we think would be the best line that goes closest to all of them. So picking 2 ordered pairs, it looks like maybe the second one and then the next to the last one maybe gets a line that's pretty close to all of them. So those are the 2 ordered pairs that I'm going to pick. Now on the quiz, I'll tell you which 2 so that we're all finding the same equation. You don't have to do 18 different ones. So that'll save me a little headache on grading. But I'm gonna use the second one and the next to the last one. Okay, and so that's the 2 I'm going to use to do my line of fit. I'm going to use 5.2 and 11.9. Those are the 2 ordered pairs that I think make the best fitting line by eyeballing it. So the line of fit is basically pick the 2 you think make it look the best. And then we're going to find the equation of that line. So if we're going to find the equation of a line, what do we need? Slope. So we got to find the slope. So 9 minus 2 over 11 minus 5. So that'd be 7 over 6. So y equals 7 over 6x plus b. And how do we find the y-intercept? Plug in one of the ordered pairs. We don't have the y-intercept yet. So we need to plug in, and you need to plug in one of the ordered pairs that you used, not just any of them. It's got to be one of the 2 you used to find that slope. I'm going to pick 5.2 because it's smaller numbers. 2, 7 over 6, 5, b. 2 is equal to 35 over 6. That's b. Subtract 12 over 6 minus 35 would be negative 23 over 6. So the line of fit is going to be y equals 7 over 6 x minus 23 over 6. That's the fraction form of that. I'm going to go ahead and do the decimal because I'm going to compare it to the line of best fit in just a second. So that's going to be y equals 1.17x minus, and then what's 23 over 6? 3.8. 3.8. Okay, so I'm just getting the decimal so that I can compare this to my line of best fit. Just see how it did. See if I did pretty decent or not. All right. So to find the line of best fit, we've already done all the long work, which is typing all your data in and then looking at the scatter plot to pick your points and going from there. So we want to do the linear regression for this, which is stat. Press over to calc. And then option 4 is linear regression. Notice in parentheses it says AX plus B. That's the same thing as MX plus B. They just use the letter A because it was first in the alphabet. And then make sure your X list says L1 and your Y list says L2. Does anybody say anything different? Okay. Frequency list should be blank. No one put anything there. Store regression equation, that allows you to put it somewhere on the calculator and let it save it. We're just going to write it down and round it to 2 decimal places. So I'm not going to go through it. Several button presses to get it to save it somewhere. So we're just going to go down to calculate and hit enter and see how we did. When I hit enter, I get a lot of information here. I get A is 1.13 and B is negative 3.86. R squared and R is your correlation coefficient. R is your correlation coefficient. 0.99, that's a positive number. So a positive number on that shows a positive correlation, right? Positive slope, positive correlation, that goes together. And then, so the R squared is how well did it fit. The closer the R squared is to 1, the better your line fits the data. So 0.98 is pretty doggone close to 1. So it's a pretty good fit to the data out of that. So we're going to write that equation down as our line of best fit. So the line of best fit was y equals 1.13x minus 3.8. Well, it wasn't 8.3, it was 8.6. I believe. Yeah. So the line of best fit, how does that compare to the line that we eyeballed? Pretty good, pretty close, right? The difference is the way the calculator finds that line is it measures the distance between the points using what's called a least squares method. A lot of calculations it does. It does several an X calculation and a Y calculation for every single ordered pair in a data set and measures how far that is from the equation of the line and then adjusts and does that. And it does a fine job doing that. So that we get the equation of best fit there. If we wanted to check that with our data and see how that fit, we could hit y equals, and I'm just going to type in 1.13 x minus 3.86 and hit graph, and you see that's the line of best fit going through there, which is that looks like it gets pretty close to all of them. Let's look at our equation that we found. I'm going to type it in here, 1.17x 3.83, and I'm going to graph both of them. Just look at them. They're real close, right? And we can see the red one goes directly through 2 of the points, but it misses this point by a lot more than the blue one does, right? So that's where the blue one kind of gains a little bit of its R squared value is by getting closer to this line, this point, and closer to that point. Loses a little bit on this one, but it's gained a lot more on the others out of that. So that's what makes it a better fitting line, or the best fitting line out of that. So a line of fit is eyeballing things. Hey, come on in. And then a line of best fit is going to be the calculator doing a bunch of calculations and finding you the best fitting line out of that. So let's do one more. Got a set of ordered pairs, and I wasn't very creative with this one, but let's find a line of fit and a line of best fit. So let's do the scatter plot and pick a couple of points, and then do the line of best fit out of that. So calculator, we're going to hit stat, edit, and I need to clear out these lists. So press the up arrow to get to L1, hit clear, enter. Press the up arrow to get to L2, clear, enter. And then I'm putting in the data. So it's -2, -1, 0, 1, 2. Not too creative with the X values there. Y values, 76320. 76320. Okay. The good thing about doing this is you've already set up the scatter plot. So when you change the data in here, it's going to automatically do the scatter plot for the new data. Your calculator's just going to say, okay, well, they got different points now, but we're going to plot them. Okay, so your stat plot that you've already done is already set up to work. So if you hit second y equals, there's nothing that you need to do here on the stat plots because you've already set it up to do L1 and L2 for X and Y. So there's nothing you have to do there. But when you hit graph, we got some other stuff going on here. So I'm going to clear out these equations from the first problem we did. And I'm going to hit graph. And notice I don't see my data. I should be seeing 5 ordered pairs there, but I see a little bit of one of them. How do I get it to show me the rest of it? Zoom 9. Good job. And now we see a good scatter plot of our data at the axes right there. So -2, -1, 1, 2, right there. So yeah, does that look linear? Yeah, I think so. So when I'm trying to find the equation line, I want to do something that fits the best. Trying to think that gets a little worse. That's not too good. Maybe those two. It's pretty close to all 3 of those. So the one in the middle, which is 0, 3, and then 2, whatever it was. So 2, 0. Okay. So those are the 2 I'm going to use. So to find the line of fit, I'm using picking 2 ordered pairs, and those are the 2 that I picked. So I need to find the slope. 3 minus 0 over 0 minus 2, which is negative 3 over 2. Does it make sense that it has a negative slope? Yeah, because when we look at our graph, that falls down to the right. So that makes sense that it has a negative slope. So when you're doing this, you find that slope, does it make sense? Check yourself and don't just mindlessly do this stuff. Make sure you know why it's doing that stuff. And here's the beautiful thing. What's great about this ordered pair that I picked? That's the y-intercept. So I don't have to do any calculation to do it. 0, 3 is the y-intercept. So I get y equals -3 over 2x plus 3. Because I had the y-intercept as one of my ordered pairs that I used. That was smart of me to pick that ordered pair. So it gave me less work to do. Okay, so decimal form, we don't even have to write it out. We know that -3 over 2 is -1.5. So when we go to compare this to our line of best fit, we can see how well we did. So line of best fit, how we get there? Stat over to calc. 4. Do I need to change anything? No. L1, L2, blank, blank, enter. Slope is -1.8. Y-intercept is 3.6. The R squared here, 0.97. It doesn't fit as good as our first example did, but it still fits pretty good. It still looks linear. The negative 0.98 there, that shows a strong negative correlation there, negative slope. And then the 9.98, when it gets closer to 1, then that's the strength of it. So if it was like negative 0.05, then it's not a very strong correlation, but it does have a negative connotation to it. So pretty good fit there. So our line of best fit, y equals negative 1.8x plus 3.6, which is really close to what our eyeballing it was, but definitely better than our eyeballing. Slope seems a little more accurate. All right, so line of best fit, line of fit, be able to do those things. Problems that you want to work on, page 291. Start with number 5, going through 25 there. So you get into a little bit of word problem stuff there, but nothing too strenuous
You want
there.
all of it or just like odd or even?
You do whatever you want. Odds would be a good place to start. Odds would be a good place to start. Okay.